Hi everyone, welcome to Ace with Ace. Today we're going to be looking at how to find the turning points for a cubic function or a cubic graph. Okay, so the steps are very simple. Okay, so firstly you'd have to find the first derivative of your function and then equate it to 0 and then solve for x. Okay, and from solving for x, with your x values that you just solved, you substitute them into the original function and find the y values. Okay, and that would be your coordinates of your turning points. Okay, let's get right into it. So we've got a function f of x equals to x cubed minus 6x squared plus 9x minus 20. Okay, so the first thing that you would do is find the first derivative. So f prime of x would be 3x squared minus 12x plus 9. Okay, so from there you would equate the first derivative to 0, and okay, so we have 0 equals to 3x squared minus 12x plus 9, and then now you'd solve for x. So there's a common factor. You first divide by the common factor, which is 3. If you divide the first term, 3x squared, by 3, you'll remain with x squared. The second term, negative 12x divided by 3, you get 4x, and then thirdly, constant, which is 9 divided by 3, you have 3. Okay, so you would end up with a trinomial x squared minus 4x plus 3, and then you would factorize, and then you'd find your x values to be 1 or 3. Okay, and then from here you take your x values and substitute them into the original function. Okay, substitute them into the original function. Okay, so if you substitute 1 into f of x, you'll end up with negative 16. So which means that your coordinate, one of your turning points is going to be 1 and 16. So the x value is going to be 1 and the y value is going to be 16. Okay, so again, you can take the, if you take the x value being 3 and substitute it into the f of x graph, you get negative 20. So which means that another turning point would be 3 and negative 20. So you'd be done. So it means for this function you now have your coordinates of your turning point. Okay, let's look at another function on your right hand side. Okay, so what we have is in your right hand side. I think it's gonna be your left hand side. Okay, on my right hand side. Okay, so you have f of x equals to negative 2x cubed plus 5x squared plus 4x minus 3, and you want to find the turning points for this cubic function. So what you would do is you'd find the first derivative. Okay, so when looking for the first derivative, we'll get negative 6x squared plus 10x plus 4. Okay, and then take the next step would be to take the first derivative and equate it to 0, and after equating to 0 we'll have 0 equals to negative 6x squared plus 10x plus 4. Okay, and there is a common factor there of negative 2, so divide everything by negative 2, will remain with 3x squared negative 5x minus 2. Okay, or 3x squared minus 5x minus 2. Okay, and then from there we'd factorize. Okay, in one bracket would have 3x plus 1, and another bracket would have x minus 2. Okay, so that would mean that our x values would be x equals to negative 1 over 3 or x equals to 2. Okay, so this is gonna be the x values. So you take these x values and substitute them into the original graph of f. Okay, so if you substitute x equals to negative 1 over 3, you'd get x equals to negative 28 over 27. So that would mean that the first the coordinate of the turning point would be negative 1 over 3 and negative 28 over 27. So this would be the first coordinate of the turning point. Okay, or the coordinate of the first turning point. Okay, and then if you substitute the next x value, which is 2, into the f of x function, you would get the y value being 9. So which means that the coordinate of the second turning point would be 2 and 9. Okay, hope that was helpful, guys. Thank you for watching. If you haven't subscribed, please subscribe and go tell your friends about it. Thank you, guys.